Hello. Welcome to another stream. Hello. Lala 23, I good Duke, Mr. Botka, Hemikovi, Kostik, go on the third, out 9. I remember Cerimon was there. The Odorcon. Hello. Welcome. So today it's Monday, and today we're supposed to be doing virtual machine development, but I don't feel like doing it today because I want to continue doing Cellular Automata. So yet again, today is going to be fourth day, hopefully the last day of Cellular Automata. And hopefully we're going to explore all of them, all of the automatas that we plan to explore in this series. So we have only 2 left, I think. And on top of that, I would like to improve the emulator that we actually wrote in the previous streams. So yeah, I actually created a couple of to-dos on improving all of that stuff. And maybe this is what we're gonna start with today as a warm-up. And by the way, you can find the source code of everything we're doing on these streams in here. So yeah, let's get started. We actually had a pretty good progress yesterday. I really enjoyed yesterday's stream. So Automaton. So what's the branch I'm using? And do we have anything in the status? Let me fetch the latest stuff. This is not how we do that. This is how we do that. Mary, need more tea. Oh, it's actually the last stuff. Oh yeah, I remember. Yeah, I actually pushed everything from this specific account, so everything should be okay. So, and let me rebuild everything. I actually introduced a separate compilation for STB because recompiling STB on each individual executable is kind of pain in the ass. Especially if you enable all of the possible optimizations like O3, and we do need O3 to actually, emulate the Cellular Automata correctly, because some of them are pretty big, like wire world, the wire world counter. It's actually like if you don't compile the emulator with O3, that specific counter is gonna be like significantly slow. You will be able to see how slow it is. Anyway. So if I try to run this entire thing, this is how it looks like. It probably kills the encoding, but yeah, so this is the thing that we managed to make running yesterday. It's a counter. I have no idea how this counter specifically works. We actually stole it from the internet, and it always shows 19, and I have no idea how to make it like increment or start at this incrementing, but it's pretty big. And the emulation goes relatively fast. And this is because of the optimizations that we put in place yesterday. One of the optimizations that we did is, first of all, O3. O3 helped immensely. Another one is that we are simulating several steps between the rendering, right? So because the rendering is the most expensive step in here, so we basically speed up as much as possible and simulate several steps within a single frame. Another optimization that we did, we're now rendering everything into a single texture. So we used to render each individual cell as a separate rectangle. That was extremely slow because it introduced a shit ton of different drawing calls, I think. I'm not sure 100% how exactly SDL works, but I would imagine that it will produce a lot of drawing calls, and especially on each draw call of a rectangle, it does memory reallocation, stuff like that, so it's actually pretty bad. So what we did here, we just allocated a single structure, and we always render into that single structure, and we just use a single draw call to slap that texture onto the screen, and it actually improved the performance like significantly. Now we're capable of emulating like pretty big structures. So bitrate is actually melting down. Okay, I see. So maybe if I like zoom in a little bit more, it should be actually better, I think, because there's not that many things that change right now. Maybe not. For example, this part is probably changing very fast. I don't know how to make it better. So I guess, yeah. So that's the thing that we did yesterday, and today we're gonna continue doing this thing. So let me take a look. I created a bunch of to-dos. And I'm just gonna go through them as a warm-up before we go into the next Cellular Automaton. Yetanasov, hello. So yeah, Wire World has been done. So the next one is probably gonna be Let Us Guess automation, automaton automation, automaton. So let me take a look at it. So it's basically emulates gases and whatnot. This one is interesting. Yeah. Literally looks like a gas simulation. Types of automaton used to simulate fluid flows. I wonder how difficult it would be to actually emulate using our life framework, because we have a framework that works really well with life-like Cellular Automaton. So yeah, we'll see. Let me take a look at some of the to-dos that we have. So I'm gonna go to Beam Snitch list, and I have a bunch of to-dos here. BB does not read its initial state from an image of a file. To settings of the board runtime. This one is actually very interesting. Camera should be controlled by a mouse. Yeah, so this is something that I probably want to implement right now as a warm-up, because I quickly hacked together the camera modification. Okay, to improve the bitrate, I think I should I can change the format of the texture. Right, if I go to the square and I find RGBA, so we're using RGBA, I can use ABGR, and it will actually use slightly different colors, and because of that the encoding is not going to be that scuffed as it is right now. Hopefully, we'll see. Okay, so wire world image, this one, yeah. So now we use different colors, and people say with these colors it actually looks better, and it actually looks pretty as well. So I'm not sure if it's true or not, but yeah. So right now we control the camera zoom in and zoom out only with the keyboard, because I hacked all of that together, right? And it would be way better if we could control that with the camera. Right, with the mouse. That's what I want to say, not with the camera, but controlling camera with the mouse. So let's quickly implement that. So I want to be able to just scroll, and then drag things around and whatnot. So yeah, let's go ahead and do that. So we use pretty, how to say that, API independent way of handling events. So we have all these like contexts of frameworks. So for example, we have a core context, and within that context we have like mouse X, mouse Y, then a boolean mouse clicked and the state of the keyboard, and essentially anyone who's using this framework, they look at these variables on each iteration of event loop, and they act accordingly. And that enables us with actually changing the underlying graphical library in the future, right? Since we're not using the graphical library types and functions directly, so we completely decoupled from that library, which is kind of cool. So yeah, right now we have only mouse X and mouse Y, and mouse clicked, which is basically, you know, indicates that a user clicked the mouse, which is really not enough for the dragging around, right? So it's not really enough for dragging around. What we need here is another thing, so something like mouse pressed, right? Which indicates whether the mouse currently pressed, right? And hold it. And we still want to keep the mouse clicked for like one-click events, and maybe we're gonna set it to true on each mouse up, so that would make sense as a single like click indication. And once we have something like this, we will be able to you know, implement the dragging around. So that should be pretty straightforward to implement. So core time to quit. So this is where we handle everything. We set mouse click to false. So, and this is where we handle all of that. So we have a mouse motion, mouse down, yeah, cool. When you do mouse down, we're gonna set mouse pressed is gonna be true, and when something like mouse button up happens, right, it's gonna be like that. So So we're gonna say mouse pressed, context mouse pressed is going to be false. We might as well actually always set the position of the mouse like this. I think it makes sense. And by the way, I think clicked should be moved to here. So now clicked is going to be indicated by mouse up. And I wonder if SDL even has a mouse click event. SDL, because in web, I think you have separate events for mouse up, mouse down, and mouse click. I guess these are like separate events, and I don't know why click is a separate thing, but maybe SDL also has something like that. Mouse click. So mouse button event. No, it only has like a button down and button up. It's purely web thing, I think. So if you check it out, web mouse up, down, and click. I think they are separate events for some reason. Click. Yeah. So click, double click, mouse over, mouse up and down, and yeah, it's kind of interesting. Element click event when pointing device button such as mouse is both pressed and released while the pointer is located under the element. Oh, both pressed and released. Okay, not only released. Hello, Enlighten on Dev. Hope I pronounced the nickname correctly. So, all right. We're kind of doing the same thing here as well. Now, mouse button down, mouse button up, and I guess that's everything I wanted to do here. I think that's everything what I wanted to do. Let me try to compile this entire thing. Just see if it's gonna work. Right, it compiled. And if I try to run a wire world, it's gonna be image www, and yeah, so I can move around. I can also zoom in. Right now we don't really, okay, I can also click, but we don't really handle this stuff correctly. Anyway, so now I have to move to the square, right? And in the square, this is where we actually adjust the positions and stuff, right? This is where we adjust the positions and stuff. So what I want to get rid of is these 4 buttons, right? These 4 buttons. Because those buttons could be implemented by dragging mouse around. Okay, so I want to move the resetting zoom to here. So this is a resetting zoom, and let me get rid of this entire thing. Okay, so if context core mouse pressed, if the mouse pressed, what do we do here? We are just looking. To be fair, what we need here is also previous position of the mouse. We need to be able to keep track of the previous position of the mouse, if you know what I mean. Because we need to take the new position of the mouse, the previous position of the mouse, build a vector out of that, and use that vector to adjust the camera location. So maybe because of that, it makes sense at the core level also keep track of the previous position. So we have a mouse X and mouse Y, and we can also introduce something like previous mouse X and mouse Y. So something like this. So basically we can make the framework keep track of these things for us. Why not? I think that will be kind of useful, because usually like previous position of the mouse is useful like generally for UI things. So that makes sense to me. So let's quickly do that. So you probably guys don't really know how this entire framework works. So it works actually in a very interesting way. Let me explain that, because I don't think I ever explained it anywhere. So essentially, let me go to a separate sort of thing. We have a context, right? So something like this, right? So here's the context. And within that context, we have an indication of Boolean like quit and so on and so forth. Right, then we have something like this. We have an entry point, like that. And then we create this context somewhere, right? We create this context somewhere. First thing we do, we initialize this context. So we have a special initializer called, actually it's called core begin, but it doesn't matter. The specific prefix doesn't really matter. So you initialize the context and then you deinitialize the context. Like the implementation of these two functions will depend on the exact library we are using. And this is one of the ways we abstract away from a specific library, which is quite convenient. So then we have another function, context time to quit, where you also provide the context. And this is where things become interesting, right? So so it returns a boolean, of course, and it takes the pointer to the context. So in here, depending on what library we are using, we're polling events. And waiting for specific events like SDL quit in case if we're using SDL. So I allocate something like SDL event here. And then while SDL poll event, then I switch upon the type of the event. And if the type of the event is SDL quit, the thing I do is I set the context quit to true, and after that I just return context quit. We might as well actually, well, I mean, it's pretty convenient to do it like that. There we go. So, and yeah, this is how I organize like a very simple event loop. And this kind of interface enables me with like later changing the underlying library of my application. So right now it's SDL, maybe later I'm gonna use GLFW, doesn't matter, as long as I can actually put it behind the interface of these three functions, it's totally fine. And now here's an interesting thing. What if I wanna, for example, do something on mouse movement, right? Or maybe I need the position of the mouse. Well, I introduce some fields like mouse X and mouse Y, and I handle the events the following way. So case SDL mouse motion, right? If we encounter mouse motion, context mouse X is going to become event motion X, right? And I repeat that for Y. So now, after I basically polled all of the events, I can just check the position of the mouse in the context, mouse X and mouse Y, right? So this interesting function, it acts not only as a predicate to check whether it's time to quit, it also acts as a poller of the events of the library, underlying library that we're using, which is actually super convenient. Right, so we just poll all of the events, we just gather all of the necessary information, and then we let the user to handle them later. So, for example, how do you detect a mouse click? Well, you can introduce something like mouse click in here, right, and then set mouse clicked to false on every every time you start this function. So at the beginning it's always going to be false, right? And then if you encounter something like case SDL mouse button up, right, mouse button up, you simply set context mouse clicked to true, and then you can check this specific variable in the event loop that you're working with. I think it's a pretty interesting approach of abstracting away from a very specific UI library, right? So, and you can check it here, and you know that on the next iteration, this variable is going to be changed. So it's only true if during this polling of the events, we received mouse click event. Yeah, what's interesting is that it will probably consolidate several mouse clicked into a single one if they happen to happen within like a single function call here, which might be a problem here or might be not. If we don't wanna miss some of the clicks in here, we can replace mouse click from Boolean to integer and basically reset the clicked to 0, and every time we detect the click, we can just add 1, and then within this function, instead of if, you would do something like for, and you just repeat some particular action several times. It's actually not that difficult to handle these kind of situations if you click several times. So yeah, is that approach interesting? I recently just decided to use this approach to abstract away from specific libraries and so on and so forth. I'm not sure how useful it is. What's interesting is that we also build a hierarchy of this kind of context. So the main context is called core, which provides the core UI functionality. And we also have another context, which is called square, which provides the functionality for square grid, Cellular Automata, right? And it keeps a copy of the core, so it has the functionality of the core plus additional fields related to square grids. And what's interesting, what could be related to square grids? Well, we can take a look at it. So we have the definition somewhere here. So here's the context specifically for square grids. As you can see, it it keeps the core context. You can still access the core context, but now instead of having mouse X and mouse Y and mouse click, it has cell clicked and cell row and cell column, right? It basically operates on a level of the grid rather than the screen coordinates, so it basically raises the level of abstraction for you. Also, it introduces the camera. Maybe the camera could be introduced on the level of the core, but it's quite convenient, at least right now, to keep the camera on the level of a square. Right, we also keep the texture in which we render the grid, and so on and so forth. You see, so we can just wrap around this context. We can raise the level of abstraction even further. We can take a square related framework and turn it into a more specific framework, a framework for defining life-like cellular automata, right? So for example, here we have specifically that context. So it includes square, which includes core. It includes two boards for actually calculating the next states, and it includes a function that calculates the rule, and so on and so forth. So you see, we have like hierarchy of this context, and yeah, at any point you can actually start working on any level of the abstraction if you need to, right? If you have a cellular automata that works on a grid, but it doesn't really fit the rules of life-like cellular automata, you can lower the layer of abstraction and start working on a level of grid, right? And then maybe develop based on that something else. The mouse clicked will be reset every time. Yes. So that doesn't work. What doesn't work? I don't understand. It always will be at most one. Yes. What are you guys talking about? I don't understand. Hello, Nitrix Life. What will not work? I don't understand. So, well, the fact I don't know how to tell you. Let me show you. The multiple clicks detection. Well, I just demonstrated you how you can solve that, don't you? Didn't you? One more time. We set mouse clicked to 0 at the beginning of the time to quit. And then if you have several events in a queue, we increment it by 1. Then after you did polling time to quit, you know exactly how many times you clicked, and you basically do the iteration over the amount of times you clicked. But it doesn't work correctly. What is correctly? Okay, so let's continue. Yeah, I want to make a cup of tea. Does anyone have any other questions? You reset mouse click 0 on every iteration. Yes, because it's consumed by the user of the function. It's a consumable resource, so to speak. So that's why I reset it. Does anyone have any other questions while I'm making a cup of tea? Do you want... I don't know what it is, I'm sorry, I don't speak English really well. I don't know what that word means. The only thing I want right now is a cup of tea, and that's it. Thank you very much. Alright, I'm gonna quickly go to the kitchen, turn on the kettle, and I'm gonna be back, and we're gonna continue developing. Do you sleep well? Yes. Alright, let's continue development. So what's interesting is that I really want you to explain how this entire idea works, because I think I came up with this idea off screen and I implemented it then off screen and didn't really address it on actually on screen. So it was kind of important for me to get it on into the recording. So now you guys know how I organize my framework, and it's actually so far works pretty decent. I didn't actually encounter any like significant problems with this approach. There are some problems here and there, but like fundamentally there's nothing too severe. Anabathu, hello, welcome to the stream. Welcome, really glad to see you. So yeah, and in the future it will really help us to basically switch to a different library if we want to. I don't really plan to switch from SDL, but if we want to, it should be relatively easy to do. Should be relatively easy to do. All right. Okay, so we have a mouse press. Okay, my tea is ready. Just a second. My tea is ready. I'm back. Yo. This is actually a very dumb solution of keyboard. I do realize that, by the way. It's super dumb. And the way I actually do that, essentially, let me show you. I ignore all of the symbols that are outside of this range. But basically, this particular approach actually does not support, like, for example, arrows, right? So you cannot do arrows in this, but it abstracts away from SDL. That's basically the price of abstraction away from SDL. I do realize the cost is Pythagoras of this thing, but yeah, at least you can handle particular things in here. I think it's good. I don't know. I think it's pretty good. And the code doesn't depend on SDL and stuff like that. So so yeah, if you open, for example, Square framework and you try to search for SDL, right? Well, okay, so there's the texture. Okay, so the problem is that the texture. But maybe if we move texture to the core, yeah, so SDL only has a texture, whatever. I think Live doesn't have SDL related. Yeah, Live, for example, doesn't have anything SDL related. Yeah. So this particular framework, it's gonna be back. Why speak Russian? Because this is an English speaking stream. That's why. A majority of my viewers don't really speak Russian, so it's kind of rude when majority of people don't speak a particular language, speak in that language, and yeah, it's it's basic things, etiquette 101. Is 0 better than doing, or is it just a preference thing? So the second one, by the way, is incorrect in C. You cannot do the second one in C. It may compile, but it's not correct. It won't do what you think it does. All right. So let me see. What I was doing, I don't quite remember. Yeah, I was trying to implement the mouse pressed, and I think pressed is true, unpressed is false, and there we go, there we go. So we also need to keep track of the previous position, I suppose. Mouse X, right. So the thing we can do, yeah, I can always just set pref minus mouse X to context mouse X, and then just simply Y. Gotcha. It works in some languages, though. I guess the first one should just be the use for good practices anyway. It's a minor syntactical thing. It's not important. Some languages support that, some languages don't. It's a minor syntactical thing. It's not even semantical one. It's not important. So if you program in languages where it's supported, use that. If you program in languages that is not supported, don't use that because you physically cannot. Whatever. Let's solve some interesting problems instead, okay? Preference then. I mean, if you program in a language where it's like literally impossible, how the fuck it's preference? Okay. So keep track of the previous mouse. Let's rebuild everything. I should stop rebuilding STV. So yeah, so now we keep track of the current mouse position and the previous mouse position, which is super nice. And now in a square, okay, so this is another thing that we'll have to address. Yeah. So if the mouse is pressed, what I need to do is calculate the difference between the current mouse position and the previous mouse position. Okay, so we're gonna have something like float dx, which is the context core previous, actually the current mouse position minus the previous one, right? So minus the previous one is gonna be prev. Like this, all right, and I'm gonna duplicate this entire stuff, and we're gonna okay, so it doesn't make it easier for me. Doesn't make it easier. Okay, so I have dx, and dy. Cool. So, and this could be a vector that we can then use to update the thing. So if I'm moving in particular direction, it probably makes sense to actually move the camera along. All right, so we can do something like that. Camera plus x dx, and then dy. Right, so this is going to be just a y. Daniel42 donated something. You need to wait a little bit because my Streamlabs is Pepega completely. Yeah. Thank you for 100 rubles. You didn't leave any message, but thank you so much. You could have asked something, for example. All right, and since you donated, I would be forced to answer some questions, but my quality of my answer will basically depend on the amount of money you donated. But I appreciate no question at all. Just keep that in mind that you can always donate with some sort of a question, and I usually try to address the questions through donations seriously, but keep in mind that the quality of my answer will depend on the amount of money you donated, right? But it's gonna be higher quality than if you asked in the chat anyway, so I guarantee that. Cheers. Thank you very much. All right. So this is how we can do that. So let's see if it's gonna do anything. Sellout? Doing things for money is being sellout? Well, you sell out as well then. Is it something bad, by the way? I don't think it's something bad. Alright. So, while... Cool. And it works. There we go. First try. Got cooler. I'm using the mouse. So, but it's probably not gonna work if I zoom in too much. No, it actually works. Huh. And it also takes into account... Huh. Surprisingly, it takes into account zoom. And I don't really understand how that works, but okay. How does it take into account zoom? Yeah, it just takes into account zoom. Alright. So, yep. It's fast now. Yeah, you missed optimization. So, but you can actually watch the previous streams in our What's channel. I didn't upload all of them yet, but eventually we're gonna have like a playlist of all of the Cellular Automata stream, and you'll be able to watch them since the beginning. Yeah. How does it make any sense? I don't quite understand. This is a C programming language. Alright, so somehow it doesn't require... Maybe I just don't understand something, but okay. Cool. So where was the to-do that I used? Where was the to-do that I used? Promo does not take into account. Camera should be controlled by the mouse. This is, yeah. I'm gonna remove this to-do. And now what I want to do is do the wheel thingy, right? I want to do the wheel thingy. So we can do it in a pretty interesting way. So it's going to be SDL wheel event. I think that's what it is. Mouse wheel event. So yeah, okay, so there's a position X and Y, and there is a direction, mouse instance, which, oh, X and Y is the positive relative of the amount of scrolled vertically. Okay, that's actually interesting. That is actually interesting. So we're gonna support only Y, I suppose. So it's gonna be core. So it's gonna be float. Maybe just int as int 32. Mouse wheel Y, right? And on each time to quit, it's gonna be context mouse wheel Y is going to be initially 0, but once we encounter mouse wheel event, mouse wheel event, so mouse wheel Y, and we're gonna just set event wheel Y. There we go. So and then we can actually use that. Don't really know how we're gonna use that actually. Will probably depend. if we have several of them, maybe it makes sense to actually add them up. All right. It's actually a pretty interesting idea. So if you have several of them in a queue, you can accumulate them and then use the accumulated value in the user code. All right. So that's pretty interesting idea. So this is going to be my minus and whatnot. If context core mouse wheel y not equal 0, it's not equal 0, we're gonna try to do something about the scale. So do we have clamp? Yeah, we do have fmin and fmax f, but I don't think we have clamp, I mean c clamp. I'm pretty sure we don't have it. Programming fucking classic. Clamp. Okay, C++ seems to be having that, but I'm not sure about C. Yeah, oh god, C, come on. Well, to be fair, what did I expect from C? C standardization committee doesn't even think that binary literals are useful. In a system programming language, in a low-level system programming language in which people develop operating systems and drivers, the standardization committee doesn't see any utility in binary literals. Just holy shit! Like the thinking about it makes me so goddamn fucking mad. Like those people should be fucking fired, straight up. Yeah, clamp is just min max. I mean, but it's kind of convenient to have it as a function anyway. That's because we have hex literals. Cool. No utility in binary literals. No utility in the standardization committee. Alright. So context camera is going to be set to, yeah, I need to implement maybe fclump, so it's going to be fclump. Yeah, let's call it clump. So, and here we have the value itself, so it's float value, and low and float high. There we go. So now we have a value f max between this thing and low, and then f minimum between this thing and high. Yeah, there we go. So now we have a clump. So now I can do clump for the context camera plus the wheel, right? The wheel multiplied by some value, but I'm not quite sure. So since it's just let's multiply it by like 0, 0, 1. Why not? And we're gonna clump it between minimum value is gonna be 0, 0, 5, and the maximum is gonna be maybe we shouldn't have maximum then. Maximum could be something like 100. I don't know, whatever. So it's gonna be f, it's gonna be f, and we don't need these things anymore. We don't need these things anymore. Why am I falling asleep? I actually slept really well today, but I'm still falling asleep. Where is my goddamn tea? Okay, need to. Yeah, I need more tea. Just use cgnu extension, which doesn't sound like a bad idea, because cgnu extensions actually solved a lot of problems that system standardization ability isn't capable of solving. We even watched like a whole talk about that. About how like GCC developers are more competent than the C standardization committee, and like they do know what C developers need, and extensions actually solve the problems in C. And yeah. Hello Kerrigan Sun, welcome to the stream. I still use you get fucking damn it mods. Ban. Permaban. Okay. But that will not actually get me my tea back, fortunately. But anyway, so we have a grid. And that's pretty much it, I think. Let me see how it's gonna work now. Why am I so sleepy? Why am I so sleepy? I slept really goddamn well today, right? But for some reason, right before the stream, I just fucking dying. Wheel, mouse, I think it's not an event. You don't have to put an event here. Yeah, exactly. So I didn't sleep. Scale. So camera scale. Oh shit, look at that. I'm scrolling. It's goddamn slow, but I'm scrolling, and it actually scrolls towards, and it's segfaulted. Yes, beautiful. How the fuck did it segfault? Nice, got cooler, by the way. What did I do to segfault that? It's not even like division by 0 or anything. It's literally segfaulted. Excuse me. But yeah, okay, so can we reproduce that? I can move things around, pretty sure I can. Okay, so let me not multiply this thing by 100. So maybe that's the reason. Oh, shut. Okay, so it zooms in really well, but yeah. We can now take a look at some of that shite. Yesu, kawaii desu. So we can take a look at it. It's really cool, actually. I really like this. I really like this. So the zoomage is really strange. It's the game over screen. No, which one? I don't quite understand what you're talking about. Where is the green game over? And I'm not even sure if I can reproduce the segfault now. So when I'm rendering everything, right? So this is how I map things. So width and height of the screen, right? Width and height of the screen is multiplied by the scale, which does make sense, right? It does make sense. Okay, then we take a half of the screen and subtract half of that one, right? And then we add the camera position. So it should always sort of zoom within. It should be always use like a center as the how to say that, as the pivot of the zooming, but it doesn't quite often. It doesn't. So here's what. So we have that 0 0. And then we do that. Don't see any mistakes in here. But yeah. Okay, if I move around here, so it still uses the center of this thing as the pivot. It still uses the center of the texture as a pivot, but not the center of the screen, which is kind of strange. We can take a look at some of the other cellular automata. So, for example, Brian's brain. That one is probably less taxing on encoding, and it also better looking one. I think it's better looking one. So let's take a look at the BB, and I can zoom in and I can zoom out. I can move things around. Yeah, there's something really weird when I zoom in. Wait a goddamn second. Maybe, oh shit, do I also have to, yeah, I have to also scale the position. That explains everything. God fucking damn it, mate. That explains everything. I also need to scale the camera position. Oh my god. Oh my god, I also have to do that. Hello, Rotten Chauncey, welcome to the stream. Hello, Cozy White Bear, welcome to the stream as well. You've been around for quite some time, I didn't notice you, I'm sorry. I'm just too busy scaling my camera, if you know what I mean. So, yesu, kawaii desu. I need to reveal everything, just a second. So maybe it's gonna be world. I also fallen asleep, I need to pump up a little bit. So that's why I'm drinking tea and screaming. Alright. Yes, now, okay, remember how I said that when I implemented the dragging around, I wasn't sure why it works as expected. Right, because I didn't expect it to work. Because of the scaling. The answer is, I just didn't apply the scaling to the position of the camera, that's why scaling didn't affect the position of the camera. Weird, am I right? So if you don't scale your position, scaling doesn't affect the position. Anyway. That makes sense. But now, once I apply scaling to the position, scaling now does affect the position, which results in a pretty expected situation. So, Wireworld, yesu, kawaii desu, Wireworld desu. So now, to actually fix this entire shit, when we're adding dx and dy, we also have to scale it according to the current scale, and that fucking explains everything. Okay, camera scale, there we go. So we'll also scale this entire thing. Let's see how it's gonna go. Alright, so, and then I zoom in, and actually we have to scale that in a, like a opposite, did I recompile everything? I think I did recompile everything. So, here's the thing. The bigger the scale, the more we have to move. The smaller the scale, the less we have to move. But why this didn't work, excuse me? Don't quite understand. Let me maybe rebuild everything just in case, because it's kind of interesting. Yes, any grid-based game equals Minecraft. Yes, thank you, Notch. Very cool. I'm really happy. Yes, that's how brain of people works. Any grid-based game. Oh, it's a Minecraft! Holy shit, this is a Minecraft! Oh my god, it's a Minecraft. Alright, so... Any game that runs on a PC. Oh my god, is this a Minecraft? You know, Minecraft also runs on PC. Is this a Minecraft? Holy shit. It's obviously Terraria. Why this shit does not work? I don't understanding. I don't understand. Right, so okay, let me see. Did I fuck up? I think I fucked up. I ask myself that question every day. That's a good question. Okay, finally it works as I would expect it. So it zooms in the center. That's perfect. 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 Perfect, perfect, perfect. Play Minetest, the open source Minecraft. I already did that, actually. I already did that. Oh, John. Hello, welcome. I think I played enough Minetest. So I don't want to play anymore. Thank you very much. These electrons going fucking crazy, mate. It's not a Minecraft. No. We already established that any grid-based game is a Minecraft, right? So this is also Minecraft. I mean, yeah, sure. I think I actually woke up finally. So I feel a little bit better. So here's that. I'm not doing anything anymore, right? So do you have to reverse the scaling? I don't think so. Okay, so it just moves too fast because... So now it's okay, but if it's like this... But we need to wake up as a Minecraft, probably. So let me take a half of it. I forget how to do the scaling of this thing every time. Okay, so that means I can... it's too much actually. So yeah. So the bigger the scaling, the more we have to like move around, if you know what I mean. But when I apply the scaling to the thing we're doing, it doesn't really affect anything. Like it doesn't affect, like I'm trying to do that and it just doesn't work for some reason. It would be nice to have some sort of anti-light. This is not what we're doing right now. We're doing a completely different thing. Context, so camera scale, we keep the camera scale somewhere here. Okay. So, I think I'm bigger. So I feel like the scale should be the opposite. We should divide by the scale. Yeah. Because, yeah. Now I'm realizing how it works. Use one scale. Thank you! Thank you so much. Yes, thank you. You helped me so much. Cool. I really appreciate you. Chat is so helpful today. Alright, so seems to be working, seems to be twerking. Zozin, just do the thing that you just did. Yes, thank you. Cool. Nice. Let's take a look at some other things. Right, so let's reveal everything. Cool. Zozin. Oh, just rewrite it in Rust and use mesh shaders. I kind of want to program in Rust. I kind of like the idea of Rust, to be fair. But there's a lot of problems that pile up in Rust that prevents me from using it. Okay. So let's take a look at the BB. So we can zoom in, then we can easily zoom out. And it looks like shit probably, but who fucking cares? Yes, so you can pause at any moment, right? You can always do something like that. Then we can continue. It looks pretty cool. So yeah, it's a pretty big world and it computes all of this stuff super quick. I really like how fast all of that is computed. Alrighty, so I think we did it, chat. I think we literally did it. We implemented the scaling based on the mouse. I'm not really happy with like how we scale back. So let me see. I think wheel could actually depend on the current scale. So the bigger the scale, I wonder if we just multiply by the scale, will it make it work nicer? That's what I'm thinking. This is not what I want. Yeah. Wire world image ww. Okay. Oh shit. And going back sends it to the moon. So maybe we have to divide it as well then. So yeah, now I'm gonna just try to multiply it and then divide. Ah! Make mine not minus b but minus g5. And only wire world. Only wire world. Holy shit, no, that was a bad idea. So I want to make the thing a little bit more smooth, but it's kind of difficult. It's kind of difficult to do that. If you know what I mean, so based on the scale, okay, so maybe if we could do something like multiply by half, that could probably work. So I need to experiment with these parameters. Alright, so, and okay, that actually works nice, I think. I think that works nice. We can probably even like take a quarter of it. Ah, Emacs. Sometimes it feels like sometimes Emacs is just slower than I type. That's what it feels like, because it like cannot keep up with the keys, if you know what I mean. It's kind of strange. Neither can Vim, by the way, because I experienced the same problem in Vim, so don't even tell me anything about Vim, because I also use it every day. All right. Alright, that's cool. So it feels actually super nice, and yeah, that's pretty cool. So we can try some other things. I wonder if something like rule 110 would work in this particular situation. Let me see. Rule 110. Does it work? Oh yeah. Yeah, it actually works. Yeah, since it uses square framework, right, it actually works. Interesting. So yeah, that's basically the abstraction level for you. That's pretty cool. So then it should also work for other things, like BB, right? Yeah, nice. So that's pretty poog. Can stop. Yes, kawaii desu. So yes, we did it. Except I also wanted to do ABGR. I want to bring it back to RGBA. And let me restart this entire stuff. So now it looks a little better. Cool. Nice. And these colors are actually also used, well, I mean, the wire world will look differently with this particular case. I'm falling asleep yet again. God fucking damn it. how it works, and it explains it here. So in quanapalos.com. So, and by the way, clicks are not translated to the world. Clicks are definitely not translated to the world, but this is something that we can do a little bit later, I think. Yeah, it's pretty cool. So, another cup of tea, maybe? Have you done any Linux kernel programming before? No. Does anyone have any questions while I'm making a cup of tea? Another one, though. Maybe I'm gonna put something on the screen for people to watch while I'm doing this kind of stuff. So, does it look interesting? Does it look interesting? Yesu, kawaii desu. I need a lot of tea today. What will be the next step? I have no idea. Creeps moving. Is this Minecraft? Yes, it is Minecraft. Is bitrate fucked up again? Like, how does this fuck up the bitrate? I don't understand. Like, it doesn't even do that much stuff. I don't know. How does it fuck up the bitrate? It's really strange. Looks bricked like a Minecraft. I see. How does it look like now? Is it better? Hopefully it's better now. Oh, by the way! What if we enable bilinear interpolation for the textures? Wait a fucking second. I remember you can actually do that. It's gonna look scuffed as shit. Holy fuck. SDL interpolate texture. Yeah. Something like that. I forgot how to do that. Hint, yeah, scale quality, yeah. SDL hint scale quality. How do you use this shit? And how do I set it? Excuse me. Set hint. Nearest. So my current plan and linear. Okay, let's actually try to use linear. So I'm gonna go to the core. And begin function. Yeah, after we initialized everything, I'm gonna just set this scale quality to linear, and let's see what's gonna happen. So we're gonna rebuild everything, and yeah, look at that. Yeah, it actually uses linear interpolation. So looks like shit on my end. Holy shit. Yes, this is how it looks like now. Who wanted anti-aliasing? There we go. We enabled it. That looks cool. Looks kind of cursed, but yeah. Alright, so what if we take a look at the BB? Let me take a look at BB. Yep. Actually, BB looks fine. Maybe I'm gonna keep it. Maybe I'm gonna keep it because it looks okay. Is it possible to disable it on some zoom levels? Yes, sure. Maybe. Okay. So maybe we're gonna put that somewhere here. Square.h. So here we control the zooms, right? So we will control the zooms. Okay. To do, use different scale quality on different zoom levels, something like that. You see? So I'm gonna put it through here. We'll see how it goes. So what else? I also had some idea. Yeah, I was making tea. I was definitely making tea. So Square framework doesn't take into account when clicking. Okay, so this is something that we'll have to do as well. So first thing we'll have to do, we'll have to map mouse like a screen coordinates to the world coordinates, and then use that to map it to the cell. All right. 2. Okay. Implement mouse-based camera controls for Square framework. And I'm gonna push that right into the repo, and you can find the source code of everything we've done in here. One more time. There we go. Oh, by the way, in README, I think, did I yeah. So by the way, if you want to test the wire world yourself, seriously, if you have SDL and stuff like that, just make the project and run wire world like that. So it requires this command line argument. It takes the image from this place, and the image is in the repo, so you should be able to do that. And you'll be able to actually like play with this counter yourself if you want to. Right, so yeah, you'll be able to click, zoom in, and on your machine you can actually witness this kind of stuff without any encoding artifacts. So yeah, check it out. Check it out, it's actually pretty cool. Seriously, like without any encoding artifacts, it's fucking insane. I really love it. So yeah. Okay, so I want to make a small break. Like around 2 minutes, and we'll see how it's gonna go, because I also need to make a tea. I'm so sleepy today, holy shit. Alright, let's make a small break, and you guys have fun. Yo, what's up? Welcome back. Oh, so we had a raid. Hello, raiders. Welcome, welcome, welcome. So yeah, I was on a break. Nice timing, by the way. Haha. So what we're doing today, we're developing a Cellular Automata. And I'm not sure if it will look good on the camera, but one of the things we implemented recently is a wire world. This is a famous example in wire world with a counter and stuff like that that we took from the website where the publication was made. And yeah, we're basically simulating it on using our own program that we developed over like 4 days. I think, yeah, we developed this program over 4 days, and it's pretty fast. It can actually simulate pretty big cellular automata. Yeah, you can find the source code here in the chat. Just a second, I need to go quickly grab some hot water for my tea, and I'm gonna be back. How do you like the quality? Oh, we have a bus error. Interesting. Huh. There is some sort of a bus error going on. Oh shit, I guess because I clicked around, I actually broke the counter. I see. That makes sense. Yeah, encoding. Encoding is perfect, I know. Okay, so let's continue. Let me see. Let's implement the idea of enabling different scale quality hints based on different zoom levels, right? So let's see how we can do all of that. Core. To be fair, to do all of that, I kind of want to extract the notion of a camera into a separate structure. I think that would be kind of cool, if you know what I mean. Also, we're starting to have a lot of geometry stuff, so maybe we should extract the abstraction of a vector yet again, because I want to be able to use vectors and whatnot. So yeah, we need to implement all of that stuff. Maybe not. So let's actually start with the camera. I'm going to introduce a structure called camera. Right, here's the camera, and it's going to have all of these things in here, right? So something like this. And we're gonna just define it here. It's gonna be camera. There we go. And in the camera, what we want to be able to do, right? We don't want to be able to do anything special. We just want to map a point to a world coordinate, from world to screen and from screen to world. That's it, right? So we need two functions. So camera to screen. So this is the first function. The second function is going to be to world. And once we have these two functions, yeah, it's pretty much going to be done. So, but since we don't have a notion of a vector, we cannot return two values. We cannot return x and y. But maybe this is the first thing we're going to introduce. Let's actually introduce like literally a vector. Why not? So it's going to be v2f. So it will indicate that it's a floating point vector, and we're going to have something like float x and y. There we go. Hello xx dv, hello. And yeah, we can just do something like v2f position. So now we have a camera, it has a position and a scale. So, and in here, we can accept the pointer to the camera. camera, which is a constant pointer to the camera, and the world position that you want to map. So it will accept the world position and will return you the screen position. That's it. So we can also, return something like, yeah, I want to indicate that this thing is not implemented. Again, false, to do, and let's do it like that. So the same goes for the toWorld, right? For the toWorld. But instead, it's gonna accept the screen coordinates, right? It accepts the screen coordinates and maps them to the world. Pretty straightforward, So, world, there we go. So how can we map the world to the screen? Well, so that pretty much depends on the size of the window, and we do know size of the window. It's actually screen width and screen height, so there's nothing particularly new in here, right? And screen width and screen height is essentially hard-coded, so it's pretty straightforward. So maybe we can even compute the half of the screen at some point. But anyway, so first I take the world, right, and I do v2 add, and what I'm doing here, I'm just adding the position of the camera, right? So I'm adding the position of the camera, and after that I want to scale that position with a camera scale, and I think that's pretty much everything that we want to do, except that the center of the camera is at the center of the window, right? So that means I also have to subtract v2f sub the half of the screen, right? So I have to subtract the half of the screen, and it's going to be essentially v2f screen width multiplied by a half, and screen height multiplied by a half. So something like this, essentially. But maybe since we're mapping to the screen, whatever actually, so 0 has to be, so we have to actually add, I think. And I'm pretty sure I fucked up miserably, but I did my best. Okay, I did my best on this one. Okay, so this is basically the expression, and I think we should return it like that. Yeah, and it should probably work. Let me think about it one more time. Right. So first we move the point according to the camera position, but maybe do we really move it according to the camera position? So I need to take a look at how we map the thing there. Right. My brain doesn't want to work today. My brain doesn't want to work, but it is what it is. Okay. So if we have a position and camera has a particular position at that, so I move the camera there, so that means I'm actually subtracting the position of the camera. I'm actually subtracting the position of the camera, but I'm also going to be adding half of a screen. So let me do something like this. Half screen, all right, so I do that, and then yes. I'm just not sure when did I scale. I think I scale kind of afterwards. Yeah, I think I scale kind of afterwards. So I subtract this thing, and then I actually add half of the screen in here. So then I just remove this entire thing, and I think it's gonna work. So half screen. There we go. So there's like an extra thing in here. Okay, so I suppose we'll need to implement all of these functions in here. So something like v2f add, right? So which takes two of these things, v2f b, and returns v2f. Maybe I'm not sure if I want to actually call it v2f. I think v2f is too noisy of a name. So let me rename it to just v2. It's just too noisy of a name, and I'm not sure if I'm gonna have like anything else. So let's just call it v2. So it's gonna be add. This one is gonna be sub, right? And another one is gonna be scale. But scale actually takes the scalar, right? So it's gonna be taking s. And another one is gonna be just a constructor, right? Just a constructor. Which accepts float x and float y, but I'm not sure if constructor is that important in this particular case because I can just use designated initializer in here and that's going to be fine. Furthermore, maybe I can do some interesting stuff in here, like actually, you know, multiplying, so v2 scale this entire stuff by a half, right? So that will automatically multiply 0.5. On each of the components. Alright, so and in here I wonder if I can just do something like ax plus bx, then ay plus by. So that's the first thing. For the subtraction, we're basically replacing plus with just minus. For the scale, we essentially do pretty much the same, but instead of second vector, we're having the scalar, like this. So that should be fine. That should be fine. So I think my tea is ready. How everyone is doing, by the way. Hello, Heroes and Plots. Welcome, welcome, welcome. So, yeah. I'm implementing vector library yet again, but in C. Because I want to have a camera. But I already have a camera, actually. It's just like I want to abstract things away so it's a little bit easier for me to work with all of that. But yeah. My brain kind of stops working today. Cheers, by the way. This is a regular tea, by the way. It's not Earl Grey. So I'm just trying to wake up yet again. I don't know. It's kind of strange. Alrighty. So we add this thing in here, and so this subtraction. So we have a position in the world, right? So this is a, we're mapping it to the screen, right? So this is a mapping it to the world. So if it's that camera. Does not modify it, but then it's going to be added. Half of the screen will be added. Okay, that makes sense. And after that, we're trying to scale, and scaling this entire thing will actually move it. It will actually move it. So if I want to add this position, well, that means I actually do that with the scale as well. So I think the scaling like that is appropriate thing to do. Yeah. Yeah. Okay, so I think this function is more or less correct. So now we need to map it to the world, right? So we take the screen, but we're gonna do the same things, but in a different order. So first we take the screen and we need to scale it back. So that means we're gonna scale it to the camera scale 1 over the scale, right? So we scale it back. So after we scale it back, we have this. So that means we have to subtract half of a screen. So it's gonna be subtract with 2 sub half of the screen. So we're subtracting that. Then we have this thing. So that means we have to add the position of the camera. Camera position. Well, yeah, Hertz and plus terminology is tricky, so terminology is tricky. Not everyone knows all of the terminology of all of the tools and stuff like that, so it is what it is. Alright, so we have this thing, right, and we have a mapping between screen and world coordinates, and I think it makes sense. Alright. I mean, like, not knowing terminology and how things works is fine, as long as you don't let your Dunning-Kruger out too much, which is not always what happens in reality, unfortunately. So, yeah. We'll have to deal with that anyway. Okay, so... Oh yeah, I have to actually mark it as V2 here, otherwise it's not going to really work that well. It's interesting. As a streamer, I've actually witnessed Dunning-Kruger on a bigger scale than usually people see it. It's actually quite amazing. You won't believe how huge of a Dunning-Kruger effect. It's just fucking amazing. So... Alright, so... and also I have to put it like this. Okay, so we also need to create the camera. Let's call it default camera or something. Yeah. So I wanna move it here somewhere. Which actually makes me wonder, do I myself know what I'm talking about? When you witness like Dunning-Kruger on such a scale, you actually start to question yourself, do I know what I'm talking about? Are all of my assumptions about things even remotely correct? I don't know. Default camera. So it's gonna be default camera, and let's return something like camera. So we're gonna have a position, and position is essentially just filled with 0, but the scale is gonna be 1. Dunning-Kruger is, yeah, that's exactly what it is. It's probably best to avoid ruminations like that and just do stuff. So we have a default camera, and then when we just assign this thing like that, default camera. All right. so let's try to recompile this entire stuff. So camera scale. So I can actually replace it like this. Camera scale. Okay. So, and here, by the way, when I'm resetting the size, it's going to be camera, default camera. So I'm just setting the default camera. All right. So, oh, this one is cool. Oh. What if I store the position of the mouse as a vector as well? That would be kind of cool, I think, but that will require moving the vector framework to a core, which probably makes sense. I think it does make sense to actually move it to the core. And let's quickly do that. So I'm gonna move it somewhere here. I'm gonna move it somewhere here. So, and now, instead of mouse X and Y, we're gonna just have a single thing, V2, which is just a mouse, and then we're gonna have another one, which is a previous mouse. There we go. So now we're gonna have all these things. Alrighty, so, and now, when I'm setting this entire thing, yeah, so now setting it should be way easier. I just reassign like a mouse to previous mouse, in this particular case though. Alright, so this one could be something like this. I'm probably required to do that in several places as well. Several places. And are we ready to compile yet? Are we ready to compile yet? Okay, this one is interesting. So core draw pose symbol. We only draw it. Huh. All right. So that means you can do something like this. Okay, that's pretty cool. That's pretty cool. So we divide it by cell width and height. Oh shit, it would be kind of nice if I... Alright, so I guess I'll have to do it like this. So what I'm doing right now, I'm doing the debugger assisted refactoring. Okay, so this is basically the benefit I can have now. I can do v2 d, where I do v2 sub, and I subtract the mouse from the previous mouse, right? The mouse from the previous mouse. And then, yeah, I now have to multiply it by inverted scale. So I'm gonna do camera, context camera equal to v2 add the current camera, and what we're adding there, oh shit, we're adding D, but V scaled Zulu to this thing over 1, like this. Look at that. So now we're using the proper vector arithmetics, I suppose. So what else do we have here? So this is camera scale, actually. Camera scale, and this one is what? A camera, it's a camera position. Get for condemned mate. Alright, so that makes sense, I think. That makes sense, and this has to be a camera position as well. Cool. Alright, so now we are mapping everything accordingly. So to be fair, so this entire position thing could be mapped appropriately. So the position of the texture, so let's put it this way. v2. V2 position, right? So the position is essentially, well, if the center is at the center of the screen, so that means we have to subtract half of the screen. So we need to calculate half of the screen yet again. Oh, well, maybe not. So it's gonna be something like this. It's gonna be screen width divided by, actually multiplied by -half, and that will automatically actually make it negative. And that's what I'm trying to achieve here. Width and height. There we go. So here's the actual position. Right. And the size, right, the size is gonna be just that, I suppose, right? No, not half of the thing. Not half of the thing. So, but now I need to take the camera and map this thing to the screen. Just map it to the screen. Just map it to the screen. So that means I'll have to put V2 in here, right? V2 in here, and also I have to provide the camera. So the camera is available in the context. So what the fuck is this shit? Oh my god, it's so scuffed. Holy shit. Fuck. It's so scuffed. A style is incapable of properly processing it. Shit. Oh fuck. A style is too old to properly process this code. Oh fuck. Thank you, A style. Very cool. It's too goddamn old. There's nothing we can do about that. So if we had this kind of function, yeah, it would work. But we can create such function, sure. Sure, let's create it. Let's create a constructor for this thing. So v2, v2, float x, float y. Ah, sorry. It scared me a little bit. X and y. So yeah, essentially that's what I want to have. And yeah, we can do it like that. So here's this half of the screen, here's that. So we're mapping it to the screen, and it will map it accordingly. But here we also have to scale the size of this stuff to according to this camera scale. So it's gonna be context, camera scale. There we go. So looks pretty pogue. Pretty pogue. Now, so I can probably get rid of all of that. And in here, for the position, we can just use that. And for this entire thing, we can just use the size. There we go. So that should be all right. I wonder if I didn't fuck up anything. We're about to find out. We're about to find out, chat. I'm pretty sure I fucked up something. Okay. Yes, I fucked up. Yes, I'm so goddamn happy. So that means it's actually going in a different direction. So, but I mean, at least it's, yeah, at least it's doing things that I would expect. All right. I wonder where exactly we fucked up. What is that? What are you talking about? Are you talking about Wild World? You never heard about Wild World? It's a pretty amazing Cellular Automata. I'm gonna assume that you're asking about what's on the screen and not in the chat, because I don't read the chat. The circuit. Oh, okay, so let's actually take a look at that, sure. So let me stash everything that we have here, because yeah, everything is broken. Alright, so let me see. Okay, so everything looks okay. Let's try to do the other thing. Let's try to reduce the size of the world, and also don't accept the images, right? So first of all, I'm gonna remove this code, and also I'm gonna go to the square and make the world a little bit smaller. Let's make it around like 20 by 20. I think that should be all right. So here is the thing about Wild World. Wild World is a lifelike cellular automaton, right? But unlike life, which has two states of the cell, alive or dead,
This one have 4 states of the cell, not 2, 4, twice as much as life. So possible states of the cell are dead, empty, doesn't contain anything, electron head, electron tail, and conductor. So these are 4 states of the cell. Okay, so here is conductor, right? Here is conductor. So in our case, conductor is orange. So the electron head is white. So I think I need to slow down the process. Yeah. An electron tail is blue. So here's the idea. Thank you, Alex. Here's the idea. So the electron head on next iteration becomes electron tail. Electron tail on the next iteration becomes conductor. So, and conductor stays the same on next iteration, and empty stays the same. Also, I think if the current cell is conductor and it has 2 or 1 neighbors that are electron heads, it becomes an electron head, which makes it possible to actually, for this kind of thing, to split apart. So for example, we have this particular wire, right? You see, we have this particular wire, and it splits actually. So because of that, 2 neighbor conductors will detect that they have a neighbor electron, and electron will split. So I can actually, you know, yeah, as you can see, it splits. What's interesting is that now I think we can do something like this. We can make it loop around. I'm pretty sure we can make it loop around. Oh, fuck. Oh, yeah. I wonder if I... Yeah, it's broken right now because the mapping is not actually properly done, but yeah. So the cool thing about this is that you can actually have diodes. You can make wires that can let the electrons go in one directions, but not go in the other ones. And by the way, all of that is an emergent property of a set of a very simple rules. Like, it's not that it was coded specifically to act like that. It's literally an emergent property of this entire thing. This is fucking amazing, I'm telling you. So the rules are this. This is literally the entire rules of the cellular automaton. So if the cell is empty, it stays empty. If it's head, it becomes tail. If it's tail, it becomes conductor. If it's conductor, it becomes head if it has 1 or 2 neighbors' head. And it becomes conductor if it's not. This entire behavior is an emergent property of this piece of code. Literally. This is fucking amazing. So this is the entire logic of this thing. Let me actually go to wire world, actually square framework. And in the camera, when we're dragging things around, mouse pressed, I think this is where it is. So now it's not going to move around when the mouse is pressed and whatnot, because it kind of messes with everything. So okay, so you can create a diode that I think looks like this. Okay, so let's actually define it like this. I think this is a diode. I'm not 100% sure, but it might as well be a diode. So we have to first make it a conductor. Everything a conductor. Okay. As you can see, it doesn't allow electrons move in that direction, right? It doesn't allow them, but it does allow them to move in a different direction. So this is literally a diode. And you can also have transistors, and once you have transistors, you can start making logical gates, right? Because basically all the logical gates based on the transistors. And this thing was proven to be Turing complete. And what people did, what creators of this cellular automaton did, they created a counter that looks like this. This is a counter. It's 800 by 600 image, and each pixel of that image is a cell in the wire world. What we did, we created a loader that takes this image, parses it, and simulates it. That's what we did. So let me show you how it looks like now. So let's... you missed the yesterday stream. So this is how it looks like. So yeah. And it works. It actually displays something. So there we go. You can check it out here. Actually, it's open source. You can try to build it. It's using SDL. So when we created all of that over the span of like 4 days, I think. Yeah, over the span of 4 days. So it was kind of cool. So this is the most interesting cellular automaton so far. We looked into the other ones, like Brian's brain, which is interesting, but not as much interesting. So yeah, it can also do a lot of different things, but yeah. Okay. So what I was doing, I was actually introducing the vector stuff, right? I was introducing the vector stuff. It feels like the scaling does not respect the center. The scaling does not respect the center, and I'm not sure why. Not sure why. So where's the camera? I don't see the camera. Because the camera is located in square, yes. Revert this stuff. Camera. Okay, so here's the half of the screen, and I just scale it, so that should give me half of the screen. Okay, that makes sense. So the position of the camera, if this is on, if this needs to be mapped to the screen, I'm subtracting the position of the wall, but I'm adding half of it. So if it's 0, I'm adding half of the screen. I'm adding half of the screen, and that should just work. So I'm not kind of sure. Okay, so let me take a look at what kind of bugs we have in there. What kind of bugs we have in there. Okay, so it moves. Yeah, first of all, the translation is fucked up, so maybe so if I move it, yeah, so it should be all right. So that means I have to subtract. Yeah, I think I need to subtract the. I need to add the position then. Okay, so I'm adding the position of the thing. And then here I'm subtracting it correspondingly. And I didn't recompile it. Okay, so that worked. But the pivot seems kind of off. So that probably means I have to subtract the half of the screen. Subtract the half of the screen. And then I have to add.
Why am I doing that? So I should not do -b here because it takes too much time. Okay, that broke completely, so I still need to do -b because it didn't really... Oh my god, incremented builders, I hate them. Alright. And at the next iteration I should not forget to remove -b. Oh, okay, so that means I did fuck up. Okay, that's very interesting. So let me get rid of this sub then. Let's actually use... Are you gonna work already? Holy fuck. Alright. So, not quite sure. So scale doesn't seem right. It should be at the center, but oh my god. This thing seems okay. This seems okay. And even if I move around, it seems okay as well. Okay. Do I have team? I still have team. Okay, so maybe I just have to scale in a different order. So I want to kind of remove this thing for now because it's not contributing too much, and we're not using it right now. So I'm going to just do assert false. It's going to do. All right. So let me think. It feels like I first have to scale it, which is okay. So let's try the approach of scaling first. Right. So I take the world. Right. I take the world, and then I scale it by the camera scale. Right, by the camera scale. So that's it. So then I need to add. I need to do the camera position that is also scaled by the camera by the camera scale, which it doesn't make any sense. Like you should be able to move it away. All right, so camera scale. Right, you should be able to simplify that. You can, yeah. So we have scale that. You have two scales in here, so you should be able to put it inside out, right? So because you're multiplying by the same thing anyway. We can even so swap this entire thing so we can clearly see that it can be extracted. Camera position, yeah, there we go. So it can be added here. So, and then we also need to add the scaled... are we adding actually it? I think, yeah, so we're also adding it to add like this scaled half of the screen, so it could be v2 scale scale half screen scale by what? By camera scale. Okay, so so it gives us that. I'm gonna comment it out. All right. So it's not really... What's wrong? Oh yeah, you cannot wrap it. You cannot swap it. You cannot swap it because it's... Alright. I completely forgot. I actually swapped it for demonstration purposes, but the order of the arguments is different. Sure, whatever. I don't care. I just wanted to demonstrate that, yeah, you can simplify that. And okay, so the problem is not that, apparently. Yeah, the problem was not that, but what's the problem then? Why does it scale not according to the center? Like, I don't understand. Let me take a look at the original code. What am I missing? Yet again, I'm missing something very, very dumb. Holy shit. Okay.
You sure you need to scale the screen half? Maybe not. Yeah, I don't think so. Thank you. That's the dumb thing that I was actually missing. So let's not scale it then. That's a very good point. Thank you. Thank you. Thank you. Thank you. Yes. Thank you so much. Yeah, I'm already starting to become blind to any of this shit. All right. So at least now we can invert the scalage, right? So we can just put it like that. So it could be just v-add world camera position, and then all of that could be scaled to the camera scale. Camera scale. Yes. So it could be simplified like that. So let's remove that, and let's replace it with that. Hopefully that will now work appropriately. Alright, so that works. Beautiful, beautiful, beautiful. That works. Thank you so much. Okay, so let's actually implement the opposite one. The opposite one also requires half of the screen. Right. So we need to take the screen and we need to subtract half of the screen, right? So after that we have to scale with 1 over camera scale, so basically scale it back, right? So we scaled it back, and then we have to subtract. What the fuck just happened? We have to subtract the camera position. The camera position. Okay, so that should be the thing. And it's a very important function. It's a very important function, and let me see. All right. Okay, so Emacs too slow. I type faster than Emacs can fucking process anything. All right. Okay, so why I was introducing this function? I was introducing this function because now I want to map the mouse position to the world, so I can appropriately detect what cells were clicked. Yes, that's what I'm trying to do here. So it's going to be cell row, right? So I have a mouse. I just take the mouse, and it's going to be something like v2 world mouse, right? So it's going to be camera to world, right? So because the mouse is in screen coordinates, right? It's in screen coordinates, and I also have to provide the camera. I have to provide the camera, and this is the world mouse. I think I fucked up something too much while trying to do all of this. Yeah, there we go. Yeah. So instead of this thing, we're gonna use literally world mouse, right? So this is gonna be the world mouse, and there we go. That's pretty much it. So now where's that thing? Okay, let's remove that. And anything else? Do we have anything else? So context, camera, it has to be a pointer. All right. Now look. This is quite important. It doesn't work. Yes, and it's segfaulted. Beautiful. I think I know why it's segfaulted. It probably segfaults because we go outside of the cells that we're clicking. Okay, so apparently cell row could be yeah, it could be yeah. So when we're clicking so I think it has to be in the life, right? It has to be in the life. Right, so cell clicked. Yeah. So, and we need to be sure, we need to be 100% sure that board current. Why am I setting it like that all the time? I could have actually set it here. So if less row less or equal than 0, it's actually less or equal than row, and row less than rows, and 0 less than call, and call less than calls, right? Okay, so this is basically what we need to do here. I think I forgot to do that. I forgot to do that, and it didn't work. Yes, I'm so happy. It literally... Oh, did I remove it? I think I removed it. Did I? Okay. I remember that for the sake of demonstration. Yeah, no, it's actually there. It's actually there. Interesting. So why does it sickle though? And why doesn't like swap things around? Let me try a Wi-Fi. A smaller Wi-Fi. So we're gonna remove this thing, and in square, rows is gonna be like 10 byte Emacs. Emacs is so slow. Or maybe it's not Emacs, like maybe it's something with my keyboard. Okay, so it doesn't map anything at all. So maybe mapping is incorrect now. So what if I don't map it? So in world mouse, right? And instead of just mapping it, what I'm gonna be doing is v2 world mouse context core mouse, and yes, so it means the world function is incorrect. Perfect. That is absolutely perfect. Cool. To world. Do I even have to world? Where's the camera? Oh, it's in square. I keep forgetting where's the camera. God fucking damn it. To world. Alright. Strange. Okay. Okay, so it is incorrect already. I can clearly see that. We subtract half of the screen. Or do we? Well, I mean, yeah. So I take a screen. So here we add the half of the screen. So that means I have to subtract half of the screen. All right, that makes sense. So then I'm left with this value, which I now have to scale back. So that means it's going to be something like v2 scale. I take this entire thing and I scale it 1 over camera scale, right? Over camera scale. There we go. So that means I'm left with this thing. So that means I can do sub, and I subtract camera position. So that should yield an opposite result. This is literally opposite operation. And okay, but I forgot to apply it. Right, I forgot to apply it. So let's actually bring it back. Oh, okay. I need to shift this thing to be at the center of this. Okay, okay, buddy. Okay. So that means if it's that, I need to subtract half of the screen. I see. Where's my half of a screen? Maybe I should extract half of a screen to separate like a vector or not, because I keep using it. Alright, so that means I need to do v2 sub half of a screen. Okay, half screen. Cool. That makes sense. Alrighty. And really subtract? Subtract. So, or add. I don't remember, to be fair. well. No, we don't have to do anything with the screen, because that's already taken into account by camera world. Well, it's not. But it's not. I made a stupid mistake one more time. Does anyone see where I made a stupid mistake? Holy fuck. What the fuck is going on with me today? Rendering is not the bottleneck of a terminal, by the way. Okay. I want to make a small break. I want to pee. Do I still have... Okay, I still have water. So it's gonna be 2 minutes. So let's make a small break. You guys have fun? Alright, welcome back. Don't quite understand. So something... What's with the mouse position? So the position of the mouse... so mapping world to the screen is actually pretty correct. Alright, so it works relatively well. So works relatively well. Oh shit! Since we're drawing every... Okay, I see what's going on. We're actually drawing it slightly shifted. Yeah, we're drawing slightly shifted, which means I have to add half of the screen. Yeah. Yeah, I have to add half of the screen. Okay, that actually makes sense. I think that makes sense. Yeah, but not really half of the screen. Wait a second. It's not a half of the screen. Yeah, I think it's a half of the screen. Maybe. Yeah.
need to brain. What is wrong? What is going on? Why it is like that? Brain, come on. You can do that, I believe in you. So you have this entire thing. Right, so you have a mouse. But then you subtract. Okay, so what if I try to subtract? Doesn't do anything. Yeah. Oh, I see. Okay, so this is another idea that I have. Here's another idea that I have. So we're mapping it as it is, and then we're mapping it to the cells. But then we have to move it half the way through. We need to move it half the way through. Which is kind of a dumb idea, but yeah. Oh, we have to add after. Yes, okay, so that explains it. Thank you so much, Brain. I really appreciate it. Okay, and we add it after because we already moved it, and the size of this entire thing is the size of the screen. That makes sense. And now, yes, it works. Sometimes it just doesn't do the thing. But it kind of does work. Okay, so it's kind of weird. Sometimes it doesn't work. It does. Okay, so I think I know what exactly is going on. So life. Otherwise, let's actually try to print them. DD is gonna be row column. So I think it just doesn't place them if they're incorrect. I think that's what happens. No. Sometimes it doesn't detect the presses. I see. So the click. How do we detect the click? Cell clicked. Cell clicked. Clicked, mouse clicked is initially false, and it only becomes true when we do mouse button up. When we do mouse button up, then cell clicked in a square. Cell clicked when the mouse clicked. And we take the mouse position and we divide all of that by that. But generally, I think it's okay. And then in life we take the cell clicked. Yeah, we just handle that. It was clicked. We'll take a look at that cell and whatnot, and it's actually usually correct, but it's still quite important to check that it's within the stuff. Wait a second. Sometimes it doesn't go through. Why sometimes it doesn't go through? Sometimes it does, but it's too fast. Huh. It's probably something with handling all of these events and shit, so yeah. But overall, seems to be working. Overall, seems to be working. Is it still clicked? But unclick works. Well, I mean, it works. Mapping works correctly. Okay, so yeah, mapping works correctly. But what the hell is going on? I don't understand. It's just so weird. One more time. I just need to observe this behavior. It's just skip sometimes if it's too fast. Because of the drag event. What is a drag event? There's no such thing as a drag event. There's no such thing as a drag event. So mouse down doesn't generate the click. We always clean the click. So in the square, G cell clicked. Alright. So we check the mouse pressed and we update it accordingly. We see any problems with that. We don't even mess with it or anything. We really don't mess with it at all. So the result is time to quit. Okay, let me actually do the following thing. Mouse... I'm missing something dumb yet again. I'm missing something very, very dumb. It's so usual for me, especially these days. Yeah, mouse button up, because I think I'm getting old. I think I'm getting old. And I need to split the screen. Yeah, it was detected. It didn't go through. It didn't go through. It literally didn't go through. Okay, so do I modify the clicked anywhere else? I don't think so. So I said it falls here and then I just check it here. So where are other places where we check it? Yeah, we only just check it. And then when a cell is clicked, yeah, and do I modify the cell clicked anywhere? I don't. It's just always synchronized with the with this thing. Live. So we use square time to quit. So then we check if square is clicked. We're taking this entire thing. Let me try to get rid of this stuff. Like, theoretically, it shouldn't even be triggered then. No. Why sometimes it doesn't work? It's just sometimes it doesn't work. And I have no idea why. It just drives me nuts. Oh! This mother flipper. It even detects them, but it doesn't fucking set them. The question is, why the fuck don't you set it? Does it have something to do with the emulation process? I'm so confused. It prints this thing. It prints this thing, but it doesn't modify the cell. It prints it, but it doesn't fucking modify the cell. So these are two lines on like next to each other. One works, another doesn't. So that means there's something with maybe rendering. This is so goddamn weird. Holy shit. So here is the current board, and this is just a... Wait a goddamn second. So do I set... Maybe that's the reason why I use the board like this in here, right? Maybe that's the reason why I put it like that. So... Okay, so, but if I put it here... Alright, if I put it here... Sometimes it may not work. So I put it back in here. Okay, I think I'm starting to understand what the fuck is going on. Okay. Alright. Okay, so I think I'm on the right track. And the reason why it happened... Do we have other boards in here? Do we have other boards? Or is it because... Oh shit, yes! I moved it outside of the while loop, so it was always pointing at the... Oh my god, I made such a stupid mistake. I'm a fucking disgrace to software. Okay, this is so fucking dumb. This is so goddamn fucking dumb. Holy shit. And I couldn't even notice that. Imagine that you have a double buffering, right? Imagine that you have a double buffering. And essentially, here's your first buffer. And here's your another buffer. And in a loop, you basically switch the current buffer between that one and that one. Imagine if you accidentally, instead of the current active buffer, you always looked at the first one and then wonder why sometimes when you render to that buffer, nothing is showing up. Well, I mean, sometimes this could not be a current buffer. And I just accidentally moved a variable to a wrong scope where that was the case. So, should stop programming. Fucking useless. Holy shit. Wasted so much fucking time debugging all of that. Where is my tea? Does anyone have any questions, maybe? To a failed developer. Any questions about what we're doing generally, something? Oh, I mean, why would you ask me? Sure. Alright, so I'm gonna go to the kitchen, turn on the kettle, and I'm gonna be back. I wasted almost 3 hours on all of that stuff. Holy fuck. Such a fucking trash. Okay, no questions, I see. Alright, so but it's still quite important to still check whether this thing is correct or not. But there's now another problem. That we need to take into account. So essentially I cannot drag shit around anymore, because when I unpress it will always set this thing, no matter what. So the question is how we can not do that. It's actually kind of cool idea. I have a kind of cool idea. So when you do unpress, right, when you do unpress, okay, I have a perfect idea actually. I really like it. So when you do up, right, we set okay, so when it's down we press true, when it's up we set press false, and we also set up mouse X. So the thing we can do, we can take the distance between the previous mouse and the current mouse. You see what I'm doing here? Right, because we have the positions, like previous position of the mouse and next position of the mouse, and it's clicked if it's less than a click threshold. Click threshold distance. This is fucking genius. This is a straight up divine intellect, I'm telling you. So I really like this idea. Right, we take the distance between them, and if it's less than particular thresholds, like if you slightly moved it, we're gonna detect it as a click. If you move it like longer, right, if you nah, you have to keep the distance. Yeah, you have to keep the drag distance, I think. Yeah, you need to keep the drag distance. Well, I mean, yeah, so distance between the current mouse and like drag distance. And we can set the drag distance somewhere here, right? And it's gonna be something like context, drag mouse, context mouse, right? So that's pretty close. Hello, Alex Bolm, please speak English. This is an English speaking stream. Majority of people don't speak Russian, so they don't understand you. Okay, so I'm gonna quickly get to the kitchen and pour myself a cup of water. Love hearing Russian though. My Russian is shit, so you don't want to hear my Russian. You have any experience? No, I wish I had though, because it kind of sounds interesting, but I don't know where to get those like microcontrollers things. It would be kind of cool. The coolest thing I probably did is I programmed like a small bootloader in MBR section. Maybe this kind of like programming on such a level is kind of close to embedded, but not really. I don't know. Check differences between event motion and context mouse before assigning position. It's difficult for me to parse this sentence. I'm sorry for my code. I don't really understand what you're trying to say. Too many things to keep track of for my brain. Sorry. Okay. So the distance is gonna be that. So we need to do. Well, let's try to compile this thing. Let's try to compile this, and here's the drag mouse. Okay. So. Oh yeah. This is kind of cool. Drag mouse. Okay, so this is that, and in here we need to have a v2 distance. And v2 distance is basically the length of the difference, right? So v2 v2a, v2b, right, v2 sub, so we're subtracting this thing and we're taking the length of this entire stuff, right, and we then need to implement the length, right? We need to implement the length. So it will tell us that we don't have a length, should be pretty straightforward to implement. Everyone knows the formula of the length of the vector from a school, right? From the middle school, maybe even elementary school. I don't know. I think in Russia it's kind of like closer to middle school or whatever. So we take x, multiply by x plus a y multiplied by a y, and then we take square root of this entire thing. Okay, alright, so what do we have here? It didn't work for some reason because it has incompatible types, because this thing is supposed to return a float as well. And let me see, so the distance, oh, and we don't have a click threshold, so let's introduce a click threshold then. So what is it gonna be? What's gonna be the distance? Let's say that the distance is gonna be 1 pixel, why not? Sounds reasonable, maybe even 5 pixels. So that will trigger the click. That will trigger a single click. And now, as you can see, if I drag around, everything's okay. And now I can actually click things and it works fine. What's interesting is that I can do something like this, boom, boom. And theoretically, it may trigger it. You know why? You know how? If you start dragging and you go back to the original position, it may generate a click if you actually precise enough, but it's kind of... So that means the keeping track of the original position is kind of like a scuffed idea, right? Maybe it should be based on the timing. Yeah, it could be based on the timing, actually. I just realized that, you know, like if you're super precise, you can actually generate a click over a long dragging, but it's kind of unlikely. But you can. You still can do that. So let's actually do that as a timing. No, I think timing is better. So SDL get tick. I think we can do something like this. So did you know that you can get ticks from SDL? Oh, it's kind of dangerous library. Oh, by the way, there is a shit ton of ticks in Academic Doc actually. Well, not in the place where I live, but we're surrounded by a forest, by Siberian forest. So in the summer, you have to be super careful while actually going between the trees and stuff like that, because there's a lot of ticks in there. Yeah, it's kind of dangerous. It's kind of dangerous in there. Yes, it's Novosibirsk. Spray insecticide. Well, yeah, they do spray the insecticide like in the pretty popular places where people usually like between the trees. They usually like the actual like roads and stuff like that, and they usually spray it there. But if you go far enough, you may go to the place where it's not really safe to be there. Ticks scare me. Yeah, they're fucking scary. Actual real life bugs. That can suckfold your body. Anyway, so here's the ticks, right? So this is basically the amount of ticks since the beginning of SDL, right? Since the beginning of SDL, and that's basically what we can do, what we can use here. Suckfolded. So what does it return? It should return. Oh, the fuck! I don't want to. Okay. Thank you so much for this wonderful library. I'm using it since the high school. I'm 30 now. Still using it. Okay. You did it go through? I don't know. It's actually true. It's actually true. So get ticks. So you int drag start time, and this is what we're gonna use there. So this is a milliseconds, right? So this is a milliseconds. So the threshold could be something like 100 milliseconds or whatnot. Yeah. So let's try to compile this. And drag start. Drag, not drag. Start time is gonna be SDL get ticks. And now, so here we don't have to do it like that, right? So start time, and then we're taking this thing SDL get ticks, subtract this thing, right? And if it's less than click threshold timeout. Yeah. Click threshold timeout. So how many milliseconds? I think 100 milliseconds should be actually okay. So yeah. Click thresholds. I think it should be something like this. Did I not click? Yeah. Timeout. Yep. Okay, so for me, it's too much. Okay, so let's actually increase it. 200 milliseconds sounds alright. To be fair, I don't like that. I think based on the distance is better. Because sometimes I may just hold it and... Yeah, I think based on the distance is better. So I just tried it, I think distance is just better. So... Yeah, let's keep the distance. Oh yeah, kill it. Alright, now... Yeah, because, yeah, based on the distance is a little bit better. Yeah, cool. So, and actually the distance could be slightly bigger than that, around 10. I'm just making it based on look and feel. Yeah. Why you killed it? I wouldn't recommend asking these kind of questions. You know what I mean? Unless... Okay, so where is the wire world? No, this is a square thingy. 60 by 80. There we go. And are we? Yeah, there we go. So I can now scroll things around, and I can also do things here. As you can see, I can zoom in on particular things, right? I can zoom in on particular things and modify them and just screw with them, right? I can just screw with this thing. And I wonder if it's gonna kill everything now. We can try to break this specific LED number now. So I can just go here and just screw with it. Yeah. Did I break it? I think I kind of broke it. Let me see if I can just do something like that. Just maybe add a bunch of things in there that will break like absolutely everything. It broke it a little bit, like now it's actually not continuous. In before bus error, yeah. Does it have a bus error? No, it doesn't have it, so it didn't detect a bus error. Okay, there's a very interesting thing in here. Let me restart it. So there's an interesting thing down there. Look at that. there is a counter. There is some sort of a counter that is not connected to anything. Here's an idea. What if we connect this entire shit? What if we connect this counter? Let's see. Okay, so it goes there. Okay, so you see, counter actually didn't stop, so it will continue sending the pulses, right? It keeps sending these pulses to the system. Will that increment the counter? That's a good question. So we have like a bunch of these counters. And I'm not sure. Doesn't seem to be like doing anything. But it keeps sending pulses, and those pulses are going down there. And I don't... There's something in here. Okay. Doesn't seem to be affecting anything. It actually filled with this kind of stuff now. So there's also DW in here. Nah. Doesn't look like we'll be able to actually increment it. Still don't understand how to do that. So there's this thing. There's also this counter. That doesn't really affect anything, it's just numbers and stuff. But they can just send a bunch of things in here, sure. You can just send. Will that do the trick? Doesn't do anything. I don't know how this counter works. I wish I knew. I wish I knew. Hello, Bitterbot. Welcome to the stream. Welcome, welcome, welcome. Oh shit, look at that. This entire thing is filled with... it's completely broken now. But it still doesn't affect anything. I'm starting to think that maybe this entire shit is just broken. So there's 19. Okay, what if I... Wait, here's an interesting thing. What if I send a pulse like around here? Okay, so I send a pulse in here. It will probably do something. Didn't increment anything. What if I send a pulse in here? What if I send several pulses in here and several pulses in here? Right, so I keep sending pulses in here. And... oh shit, look, 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 look! Fuck! It's so cool! I need to restart it. I'm not sure if you can see that. Just a second. Oh shit, I think I managed to like swap a digit or something. Holy shit. RGBA. So let me switch to RABGR, so the colors are a little bit better, because with the encoding the colors should be better. Okay, so we have like 19 in here, right? So what did I do? I think I sent a pulse in here. Like, let's actually send a pulse like this. So here, this will send a pulse to this entire thing. Okay, let's send it a pulse. Will that increment this thing? Or do something with it? Oh shit, look, 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 look. Holy fuck. It's changing. It's dead. I killed it. I completely killed it. Beautiful. What if I send another pulse in here? Another one. So nothing particularly changing. Okay, so what if I send the pulse to the other thing? Okay, so it starts to cascade, and it will probably just propagate and set the value to something. Yeah, there we go. It sets the value to... it's kind of broken, but it's trying. Nah. Yeah. Remember that I managed to do something here. So this sends these kind of pulses. Oh, now they're all zero. Yeah. It's really strange. Maybe this is the counter. Nice number, yeah, thank you. Wish I knew how to work with this thing. So it's gonna feel it right now. So it's feeling it. Cool. So where is this ABG? Oh, by the way, so Hamikovi, remember how you posted a link about the Tetris Effect game, right? So it's actually super cool. I think I recently developed like a Tetris Effect from this Cellular Automaton. Alright. Okay, so what did I do in here, by the way? Did I introduce it to do? Squarefront doesn't take into account camera when mapping. Okay, yeah, this is basically what we did. We now map the clicks accordingly. Map cell clicks according to the camera position and scale. And let's push that right into the repo. So, yeah, that's pretty cool. That's pretty cool. Do we have anything else to work on? Different scale qualities on different zoom levels. Square power doesn't take into account camera when mapping. Really? Didn't I just fix that? I think I forgot to remove that. Right. Mapping clicks on the cell. I think I literally actually fixed that. Remove to do. Alright, so one of the things I wanted to do actually, right now the size of the board, right, is hard-coded. The size of the board is hard-coded. Yeah, so you have rows and you have columns, which is not particularly convenient, right? Because it's a compile time value. What I want to be able to do, I want to be able to set the size of the board at runtime. For example, in Wire World, right, when you load an image, I want to set size of the board to that specific size of the image, without like having to change these two values, if you know what I mean. Right, so this is basically what I want to do. But I wonder how much refactoring that will require, but it will enable pretty cool shit. It will enable pretty cool shit at some point. So yeah, I think I'm gonna go ahead and try to code it right now. So I want to make a small break super quick because I need to refill my water, and after the break we're gonna continue working on all that. So it's gonna be, now let's put 3 minutes. Yes, so all right, so yeah, have fun. Yo, what's up? Welcome back to back. So let's try to tackle this problem of runtime size of the board. Right, it's going to be very interesting to do so. So the first thing we can do, we can just remove these things. I'm gonna simply comment them out. Right, so that will cause the chain reaction of the compilation, and we can go through that and just fix all of that. So another interesting thing is that we will have to provide the size, like rows and columns, in the structure in the context itself. So let's quickly do that. So it's going to be something like rows and columns, and we might as well actually accept them, like force user to provide them in here, right? So when you create a square context, when you initialize it, you will have to provide those things, and we're gonna automatically set them here. So it's gonna be context rows, and then it's gonna be the columns. There we go. So, and let's start the chain reaction of compiling everything. So it's gonna be something like this. Yeah, let's just recompile everything and just go through everything. What do we got? So yeah, when we create the texture, we have to provide columns and rows, and it's actually kind of easy to replace all of that. You just do context rows and columns. It's pretty easy, pretty straightforward, as Mr. Zozin likes to say. Via world, there we go. Why am I talking about myself in third person? I don't know. So cell width and cell height. We can pre-calculate cell width and cell height, I think. I think we should be able to do that. So let's do something like this. Cell width and cell height. Right, after we set all of that in here, we can just pre-calculate all of these values. It's pretty straightforward. Is this a divine intellect? Probably. Cell width. We take screen width. Smart people can talk to themselves in third person. I don't know. Probably. Who's Nika, who's Alexi, who's Mr. Zozin? It's they are different voices in my head. So all right, so this is gonna be width, and we divide it by rows, and no, by columns, excuse me. So this one is gonna be height, rows. Long time, yeah, haven't seen you in a while. How are you doing? Where have you been? Okay, so now what we have to do here is something like this. Context, cell width and cell height. Is going to be context rows. And this is a context columns. Oh, this one has to be now. Ooh, all right. This is very interesting. So I made it int. So maybe now I have to refactor all of that to be size t. But I'm not 100% sure. We'll see. We'll see. The winner gets t. That's for sure. Haha. Context like this. So another cell width is going to be part of the context. Context, boom. So what else do we have here? Okay, so we create a rectangle. It's going to be context like this. Context like this. Oh, and this one is the most interesting one. Yes. Because the size of the board as a type is defined in terms of the compile time values of rows and columns. Now we cannot do that anymore, which is kind of sad, yeah? And I wish I could somehow like parameterize the struct with sizes of the dimensions, but I cannot do that. I literally cannot do that.
Which makes me a little bit sad. So the only option that I can have here is to turn this entire thing into cells pointer and actually do a pretty nasty arithmetics. But what's interesting is that in structures we have something called flexible array member, right? So we have a flexible array member. The question is, can a flexible array member be multidimensional? Is that a thing that it can be? A multidimensional array member. Multidimensional flexible array member. Probably not. But we can try to test it out. So let's create a special thingy, main.c, and we'll see. And main is gonna return. All right. A lot of work. I see. I also have a lot of work and no time for Twitch. Unfortunately, it is my work. I cannot escape Twitch. Okay, so we can have something like this, and this will work, right? So, yeah. Okay, flexible array member with no named members. Ah, I see. So that means it expects at least that. Yeah. Now, another thing. Can I do something like this? Array type has incomplete type int declare. Okay, here is an interesting question. Can I do something like this? That would be goddamn fucking pogue. And you know why I'm asking? Whether it's possible. Because something like that is possible in signatures of the functions. Right, you can do the following thing. You can do int row, int column, and then you can declare access row and column. I think it is possible. Not 100% sure, but I think it's possible. It's possible. Seriously. And then you can do something like for int I less than row, then for int j less than column, right, then plus j, and you can do something like access ij69, and it works. See? So this type checks. So this sort of helps the compiler to know how to offset like array by rows, right? It by no means makes it more type safe, because the array still decays to a pointer. There's nothing you can do about that, but it provides additional documentation and also additional information for the compiler how to offset and index properly multidimensional array, which is already pretty great. So it is possible on the level of function arguments. Question is something like that possible on the level of the structures? And to be fair, I don't see any problems why it wouldn't work like that, right? I don't see, like, if I were implementing the C compiler, I can see how to implement that. It's not that difficult to generate a code that would actually use this field of that structure to offset things properly. And now the moment of truth. Does it work? No, it fucking doesn't. Welcome to 2021. I'm sorry. Did you mean A2L? Yes, that's what I meant. Yes, thank you, compiler. Very cool. Thank you. That's very pogue. Okay. Because it's kind of an isomorphic situation, if you think about it. Like, this is very similar semantically to this. But yet, you cannot do that. No. I don't think so. Also, what about one-dimensional ones, right? So if you have something like that, it is not possible. I don't know. Nah. So the best thing I can do is probably something like this, right? So it's probably something like this, where I have a rows and columns, right? And then a flexible array member, and I basically always access it like this, right? So I have access board rows multiplied, actually like I multiplied by board calls, right? This actually has to be plural, plus j. So this is basically how I have to access them. But in struct you can only set one field. In function you have all of them. What? You can set one field. Excuse me. Board. Okay, let's actually check your hypothesis, right? So I'm setting one field. Alright, so here's, I set one field. Rows. So according to your message, I shouldn't be able to set the second one, right? So this should not compile. Is that what you're saying? Struct size must be known at compile time. That's why it doesn't work. No, the size of this array is not known at compile time. And it works. See? It works. Wait, how does it work? The size of this array is not known at compile time. It decays to a pointer. No, it's not. If it decays to the pointer, okay, so it decays to a pointer, that means that size of board has to be equal to size of actually less or like greater or equal size of this, and the pointer to int. So size of int multiplied by 2, right? So because we have two ints, plus size of pointer to int, right? If, according to what you said, it decays to a pointer, right? It's a pointer. So that means the size of the structure should be equal or greater because of the potential padding. Two sizes of int, because we have two ints, and one size of int pointer. Do I understand you correctly, Rodriadus? Is that your hypothesis? I think it's a non-standard GCC extension. It is standard. That's what I meant. Okay, let's actually check it out. Okay, so let's see if you're right or wrong. So here's the size of this thing, and are you guys get ready? Are you guys get ready? Why is the size of the board significantly smaller than this? Because the size of the board has to be greater or equal to this, but it's smaller, it's twice as smaller. What's wrong in there? You tell me, you know C better than me, you tell me why it's smaller. It has to be greater or equal. And it's standard from starting from C99. So as a matter of fact, right, if you remove this thing, they become equal. So size, when you do size of board, it doesn't take into account the size of this thing. It considers this thing to be equal to 0. This feature is called flexible array members. Flexible array member. There we go. Educational stream, by the way. There we go. And it is a standard starting from C99. It was a GCC extension before C99. Now it is a standard, right? And the size, basically, the C compiler allows you to put an array of an unknown size at the end of the structure. Only at the end. It's only at the end. If you try to put it somewhere in between, it literally won't compile. It will tell you flexible array member is not in the end of the structure. It has to be at the end of the structure. And the whole discussion that we had was, can I have flexible array members that are multidimensional right? And also specify their sizes like that for the point of documentation and for the potential benefit of compiler generating a proper code when I'm trying to access this thing like that. And as I already said, if I were a C compiler developer, I wouldn't see any problems implementing that and generating proper code, because the only thing you need to do, you just need to grab the dimensions from the structure itself and just generate code accordingly. So that's what I was talking about. Does it make sense? Is this well behaved? Depends on what you mean by well behaved. What do you mean by well behaved? So essentially this is needed for structures of a known size, right, where you have a metadata which describes the size of the of this array, right? So essentially to allocate some memory for this board, you would do something like malloc size of the board, and this is basically the size of the metadata multiplied by the size of the element, or maybe we can do it, yeah, element multiplied by how many you want to allocate. Right, and that allocates enough memory for that structure. And flexible array members guarantee that this amount of memory will be enough to feed this in a whole structure, including potential padding and whatnot. Right, including potential padding that you may have there. So that's pretty much the whole point of this feature. So you can do these kind of things. So it's actually a pretty cool feature. And yeah. So I guess the only thing we can have here, is a flexible array member, rows and columns, right? And basically, if you want to try to access the cells, you have to compute everything yourself. So it is what it is. But the problem with such approach would be that you don't have to initialize all array members. For example, rows might not be set. You don't have to initialize all array members. For example, rows might not be set. And when they're not set, what they're equal to? They're either equal to a garbage or do they equal to the 0? And I don't see any problems. So if they contain some arbitrary values, well, that means the arbitrary value is going to be used for the offset. I understand. Or do you assume that these things should be known at compile time? I didn't mean that they should be known at compile time. They could be known at runtime, and compiler still will be able to generate the proper code to offset things. I don't see any problems with that. It could be unsafe, but I mean, it's C. All right. So anyway, essentially we have to do the following thing. We're gonna have rows, right, and then we're gonna have columns, and that will spawn a next wave of compiler-assisted refactoring. And it doesn't compile because I'm compiling bullshit. Okay. So yeah. I like to compile bullshit. I wouldn't want compiler to generate an array of with some garbage that might be in the memory rows on the stack, but okay. We probably don't understand each other, so this is not what I meant. All right, so here's the board. So I also want to be able to create a board of a particular size. So allocate. And what's funny is that you cannot easily allocate this kind of array on the stack, right? So if you, I mean, this kind of structure on the stack, right? You cannot literally allocate it on the stack, and this is actually kind of sad. This is actually kind of sad because, yeah, well, you can just make an array. Like you can always do something like uint 8t x, right? And 0 initialize that and just do something like size of board
multiplied by size of cell multiplied by your rows and your columns, and this is how you can allocate. So basically use VLAs, right? Basically use VLAs. And then you will have to take, you will have to reinterpret that array, right? And I don't think it's particularly convenient approach. So, but at the same time, I don't want to use the, well, I don't want to use the dynamic memory. Probably have to use the dynamic memory. Yeah, probably have to use the dynamic memory. Board new, so it's gonna be size t row, size t column. It's gonna be malloc, size of board multiplied by size of cell, multiplied by row, multiplied by column, right? So that's basically what we have to do here. This is basically what we'll have to do. So we're iterating through all of that. So then we're using this stuff from the board. Actually, I don't have to do it like that. It's gonna be board. Yeah, and here's the problem. Like I don't now. I need to change this thing. And I can make a pretty bad mistake trying to access this entire stuff, right? And I want to have some sort of a macro, basically cell, which accepts the board and row and column, and essentially what it should do, cells, you take the row, you multiply it by the board columns, right, plus the column, and that's how you can access this specific cell, right? So now I can rewrite something like this: cell board and just a row and the column, and that enables a pretty easy refactoring, right? So essentially I have a macro that, given a board, extracts the board columns and makes the correct offset. Is that a useful macro? Look at this macro. I think it's a pretty useful macro. What do you guys think? Right, so yeah, I think it's a pretty cool macro. And interestingly enough, this is what I meant by generating the compiler. So essentially, I want the compiler to generate this kind of code when I do something like this. This is what I meant. Right, so you have the definition of the board. You have the definition of the board. Rows, columns, telling the compiler which variables to use for which dimensions to calculate offsets. And then when I do something like that, it generates this. You see what I mean? This is what I meant. Is that too dangerous of a code? So I'm not sure if I expressed myself really well, but that's basically what I meant by being able to do this kind of stuff. So it will turn this into just that. What's the math called for rows and columns? Yes, what? I don't understand. I don't know if it has any math. I don't know if it has, I mean, if it has any name, but yeah. So, and again, I don't see any problems compiler doing that. And if you set calls, if you don't initialize calls, this code is as dangerous as this one.
Right. But the only problem I can see is that it tries to access calls implicitly, and you might be not expecting that. And yeah, but again, it's C. C also has like a lot of unexpected things, but at the same time, it's actually pretty convenient. So it's also pretty convenient. All right. So here's the cell board, a row cell. Okay, let's try to compile that. So now we're iterating all of this, and it's going to be board rows, board columns, and now I can just do cell board row column like this. It has to be size T. Okay. So we have two boards, but apparently now we have to have two pointers to boards because we're going to be allocating them on a dynamic memory, right? So now we're allocating them in dynamic memory. Okay. So now I'm copying this entire stuff. So it's going to be board. This one is going to go like this. And we can do cell board row column. It's going to be like that. So data rows and columns. So we can try to allocate that on the stack, which is so live save board to image. So we're trying to allocate this in the stack. Is it too dangerous? I think it's kind of too dangerous to allocate that in the stack. So maybe it would make sense to yeah, to not do that. Though we did allocate it before in the stack, so maybe it's not that bad. So board rows, board columns, with a row cell color is going to be cell. Oh, variable sized object may not be initialized. Okay, but we're gonna actually set it anyway. Storage size data isn't constant, but I'm using C11. Ah, I see. See, each individual row is actually fixed size. You cannot allocate things like that. I see. God damn it. Making the runtime size of the board is actually super super annoying. Holy fuck. It's so goddamn annoying. But yeah. But it is constant. In here, so come on, compiler. I believe in you. Cool. So what I need to do now here for this specific thing, I also have to struggle with the proper computations and stuff like that, and I cannot use this syntax anymore, unfortunately. It just makes me goddamn so sad. But at the same time, do I really need to do that? Because I can always do something like this, right? And right, I can always do something like this, and I can so the current row is the board calls plus column, right? So board calls plus column,
and that should be all right. So yeah, don't see any problems. So board calls board rows, and then we have board calls. Oh boy, oh boy, oh boy. So how many? Yeah, let's not do that. So it's too deep of a rabbit hole. Storage size data isn't constant, but didn't I say? Okay, okay, buddy. So, oh my god. Let's allocate it on a dynamically. Sure. So it's not that big of a. It's not that often of a operation. So that means, like, doing something like this shouldn't really affect anything. So yeah, right. So we only like allocate it and free it one time, like when you press a key. So it's not happening. It's not happening every frame. Oh, static. Thank you. I forgot that I have static. Yes. Thank you so much. I forgot. It. Yeah. I just put it there and I forgot it. Okay. Board equals. Anna, did you see my explanation of what I meant by compiler generating the code based on fields? Or, I don't know, were you AFK? Okay, sure. So, let's continue. I'm so tired. Holy fuck. So we have asserts and board. So width and height in this particular case, so it's integer. I think I can safely cast it to size t in this particular case. In this particular case, so board rows. Board rows. So what I'm thinking is that what would I consider an ergonomic language? What would I consider an ergonomic language? So a language where changing from, let's say, something like this to something like this. Right. So a language where from changing from this board where the size of the board is known at compile time to a board where the size of the board is known at runtime doesn't require modify the places where the board is used. So that's what I would consider an ergonomic language. See what I mean? So essentially, because semantically these things are not that different. The only difference is that the sizes are known at compile time, now they're known at runtime. So, and I think I'm starting to understand why in Ada the sizes of the arrays are such a weird entities that are kind of known at compile time and runtime simultaneously, and the sizes can act both as runtime and compile time values. So I guess it is needed to enable this kind of optimization, but this kind of refactoring. But I'm not sure if refactoring, this kind of refactoring in Ada is going to be easier because I never tried that. So yeah, the fact that I have to go through all of the places and change everything in C, it's very inconvenient, and it's just like a flaw in the design of the language. But the design of C is good for 1970s. 1970s. It's not really good for 2021, for sure, because the programs are much complicated than 50 years ago, and yeah. Anyway, just wanted to point that out. That I really don't want to do that. But I'm kind of forced to do this kind of stuff. Yeah. Alright, square begin, and okay, so we're starting to actually use this kind of stuff. And now we have an initial board, and we can now make a square begin of the size of that board. We can just provide rows, right, and columns of that specific board. Alright, so now we have this kind of situation where, so what we're looking at, I need to have board rows and board columns. Cool. Oh, okay, and then here, this one is very interesting. You could do cell. Oh wait, cell. Does cell assume... Okay, and cell assumes a pointer, which makes it even funnier in my opinion. Right, what if I don't have a pointer to the board, right? What if I have a value of the board, right? What if I have a value of the board and I need to use it? So that means I'll have to do something like board, and that will generate a pretty funny code where I take the pointer of the board and then dereference it with arrow. But I mean, it's not for human to read anyway, so... fucking classic. Alright. So... Okay, so we take initialization of the... Oh yeah, that's cool. Humans don't read it. Haha. Comparison of int integer. Okay, so this thing has to be size. This has to be size. Oh. Oh, thank you very much, compiler. Very cool. What's up, Jia Yang? Hello, welcome to the stream. How are you doing? How's your prologue adventures? Hope you're well. Alright, so we take this thing, and then we take this thing. I'm doing a pretty shitty refactoring because of the flaws of the design of C. And I want to be doing that, but I'm kind of forced to do that anyway, so I don't have to do that. I don't have to do that, that's for sure. Yep, and this one is interesting actually. So I'm iterating the Rust compiler and prologue. All right. So I'm thinking, so live accept initial board. Maybe we would be able to move that board inside of the thing. All right. So what do we have in here? That's going to be cell. So the thing is kind of annoying, to be fair, because rows and columns have to be equal here. So we make some sort of an assertion that rows of previous are equal to the rows of the next, and columns as well. So this is kind of a pretty important assumption. If it's broken, our code is broken. And now we should be able to do the following thing, where we do next rows and next columns. And now, what do we do? Context rule. Okay, it's gonna be cell. There we go. And then we swap this entire stuff. Yep. And this thing has to be size T. And you don't have to do
that. All right, love it. Board calls. Chat. My brain is dying. What do I do? Chat, help. Yes. Okay, I managed to make Wild World compile, which is already pretty goddamn fucking impressive, not gonna lie. But the thing I don't do here, let me go to the live go. Right, live go. So we have initial board, but I wanna, instead of copying init board, what I wanna be doing is, yeah, so you see we're copying the board, but that's not what I wanna do. That's definitely not what I wanna do. I wanna like literally reuse it. So the current board is gonna be context boards 0. It's actually, yeah, this is gonna be 0, and we're gonna use this as an initial board. And yeah, so basically the user has to allocate it for us, and then boards 1 has to be board. How do you allocate the new board? I don't remember. Square H board new. Where was the malloc where I defined the board? Oh, but board is actually, yeah, so board new. Okay, so board new, and we use the rows and columns of the initial board. Init board rows, init board columns. There we go, and we don't have to set anything in here. There we go. So afterwards, maybe we want to actually deallocate all of that. I think it does make sense to deallocate all of that right before calling this thing. So we're going to do it like that. All right. It does compile, surprisingly. Okay. I'm just a little bit afraid that maybe the type system didn't detect all of the possible places where I need to make these modifications. So let me try to recompile everything. Okay, so now, yeah, we have this kind of situation. Oh shit, this is cool. Oh fuck. Oh shit, oh fuck. Ugh. Shit. Okay, so we have to do a similar optimization, similar refactoring for rule 110. So we can also use the I got the name, flexible array member. But yeah, that will require. Okay, let's not do that yet. Let's actually focus on the while world, right? So let's focus on the while world. So now, the problem with the while world, now you have to create a board of a very specific size, right? And live load board from image. We have to modify this function to actually allocate the board on the stack. So, and this is, okay, this is actually kind of cool. We're gonna go to the live.h, okay, live board from image. So, and I think this thing should return a new board in here, as you can see. Yeah, so we accept file path and stuff like that. And we're gonna take the size of the board from there. So this is the refactoring I have to do. Alright, so let's start with the refactoring. And here's how we're gonna do that. I'm gonna allocate the board, board new, so H and W, there we go. I'm not sure if I want to check this thing specifically. Right, it's because, I mean, it's kind of, it's gonna be kind of cool. That's the point. So then we're iterating through the board, and at the end we should return the board. There we go. So does it compile? Yeah, now the board is taken from the file image. Yeah, so you see live go, and I'm loading the board from an image. So we also have a cell count, and is it gonna work? It seems to be working. That's cool. So that now the size of the board is taken from the size of the image, theoretically, but I'm not 100% sure. So if I do wire world images this thing, and it will do compilation floating point exception. Cool. Floating point exception. So I think I know where it fucked up. And I forgot to actually set everything. Yes. So this one is going to be just board, right? And it's going to be something like board rows have to be equal to rows. This is columns, rows and columns. This one is going to be columns, and then we just return the board. So that should do the trick. And I didn't recompile everything, so let me quickly do that. I only want to recompile via world. And what do we have here? There we go, it seems to be working. Yes, I finally refactored everything, and I think it became slower. I feel like it became slower, kind of. It's hard to tell. But it could be because we have like several layers of indirection. That's probably why. Yeah. But it is what it is. So I refactored the code from knowing the size of the board at compile time to knowing the size of the board at runtime. Did we figure out whether the counter needs input or is it just running slowly? I think it needs input because we waited for quite some time. And the only way to actually change anything is to probably just send a couple of signals in there, and it doesn't work. Excuse me, it doesn't do shit. Well, that's very interesting. Let me try to maybe stash my changes. Okay. Right. It feels way faster, by the way. Yeah. So if you send a couple of pulses in here, it will probably change the thing in there. Not really. We can try to send a couple of pulses in here. So let's actually send them like that. Okay, so yeah, as you can see, it starts moving and changing things. Yeah, but it will break it essentially. It will essentially break it. So you have to mess with these things in here, and it's, yeah. Do we have a bus error? I don't think we have a bus error. Bus error seems to be okay. Glitch the digit. Yeah. Now it's 33. Interesting. That's kind of cool. So, 33. Anyways, so there's something broken with the runtime value thing. Because it doesn't map anything at all, like at all. The question is why. In a wire world, maybe we should create something slightly different, right? We can try to create something like this. Board new. Let's create a 10 by 10, right? So, and we can do that now. We can just create a new board, and this is going to be the initial board, and it's going to be duplicated and whatnot. Oh, and it seems to be working. Okay, and even if I zoom out, it still works. Okay, that's pretty cool. And
Yeah. So, but if I change it to loading from the image, for the image it doesn't work, which is really strange. But okay. No, it doesn't allow me to click anything. It's just I'm confused, but okay. Huh. Yeah. So maybe it's because it's too big or something? I don't think so. But on the smaller boards, it seems to be working. On smaller boards, it seems to be working. Just made a pixel art tool. Not really. So if we take a look at the game of life, for example, right? And here, I'll just remove this entire thing, and I'm gonna just do board new, 10 by 10, and let's put it this way. It's gonna just go. Oh, yeah, okay, that makes sense. Cell. I need to refactor it really quick, otherwise it's not gonna compile. Yeah. Yeah. Yes. That's basically what we have. It's not really that. Essentially. So, Wire World. I think I know what happened. No, this is not what happened. It just doesn't allow me to click. Something is wrong. Oh! Okay, it does like register the clicks, but they're fucked up yet again. Okay, that's really strange. Like, why would they be so fucked up though? So cell, cell clicked. Let me see. Cell clicked. Cell width and cell height. And do we even? Okay, so maybe it's not pre-computed properly. Cell width, you take the screen width divided by cos. Well, it should be pre-computed properly. So the only reason why I would see it's not like properly computed is because yeah, we can try to print them. Oh shit, I want to pee. Cell width, context, cell height. So let me take a look at them. All right, it's equal to 1 actually. Wait a second. Oh, I need to make a small break. Fuck. 2 minutes. Alright. Have fun. Ah, fuck. Have fun. Oh, I feel like this refactoring is too much of a rabbit hole. But I think it's gonna be worth it because it will enable a lot of cool things. So screen width, in how many places do I use screen width? I actually use it quite a lot, specifically in Square, but I don't use it that very often anywhere else. So I think to fix this kind of problems, right, we need to make screen width and screen height also a runtime values of core. I think it also has to be that. So let me take a look at what it's... yeah, I want to print this kind of things. In a wire world, maybe, no, not really wire world, but actually live. If clicked, so if cell is clicked, I want to simply print the value that was just clicked, right? So it's gonna be a row, okay, ZU, row and column, there we go. By the way, maybe I actually defined the thing incorrectly, so I take the row, I'm using columns of this thing, and yeah, I think I did it correctly. I didn't see any mistakes in here, so should be all right. Okay, so if I click something and it doesn't even work, holy shit, it's slow. It doesn't detect any clicks at all. Oh, because I didn't provide the new line, and it didn't properly do that. It didn't flash it because it, you know, flashes in the new line or whatnot. Okay, it goes over, so it makes it like... Well, it starts to deviate a lot around this time. I know that it kills the stream. You're not the first person actually noticing that. I'm sorry. Okay. So... what I was thinking about, I don't remember. This is actually very complex refactoring, and the fact that it also kills the performance makes me kind of sad, right? Because if you just remove this entire thing and make it like compile time available, maybe like knowing the sizes at compile time enables pretty good optimization because it's so goddamn fast. Yeah, when it's known at compile time, it's just goddamn fast, but if it's a runtime thing, it just doesn't work properly. It's kind of sad. But yeah, do I want to continue pushing this refactoring? It would be kind of cool. But I'm a little bit tired already, and well, I'm already streaming for 4 hours. So I guess this is gonna be the last Cellular Automata stream, right? Because yeah, there's so many things I wanted to do for this project, but this project is not really useful for anything. So I guess we explored enough of Cellular Automata. It was interesting. But I guess it is time for us to move on to something else, maybe to virtual machine. I'm not sure if this particular refactoring was useful at all. It was interesting, and it was interesting to discuss this idea of flexible array members, like multi-dimensional flexible array members. Would be kind of cool if C compiler supported that. I still think it's kind of cool. It would be kind of cool. But unfortunately, it is time for me to go, boys and girls. It is time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I'll see you all tomorrow. Tomorrow, according to the schedule, we're gonna continue doing virtual machine. Right, we're gonna continue doing the virtual machine. Check out the schedule page for more information on different projects we're working on. Check out the source code of the project that we worked on today. Check out our VODs channel. All of the Cellular Automata streams are going to be there. And check out our Discord server for offline discussion with the community. And that's it for today, boys and girls. That's it for today. Love you. Mwah.